So here's number 3 on the practice test. 100 grams of magnesium are reacted with 300 grams of O2 according to the following reaction. Which is the limiting reactant? Okay, this is part A. So what I'm going to have to do is I'm going to have to compare this magnesium, figure out how much of a product I get, and then I'm going to have to compare the other one to one of the other products, and then just figure out which one is less, right? So the only issue with this is that it doesn't tell me specifically which product to pick, to compare. So what I'm going to do before I start is look down at part B to see if there's a product specifically that I'm interested in, because that could help save me some time. Part B says how many grams of ozone will be produced. So this is going to be the best product to compare these guys to, so that we don't have to do more steps than we need to. All right, so let's begin. Now that we know what we're doing, let's begin. So we have So we have 100 grams of magnesium, and we're going to convert that into moles. That's going to be easy because magnesium is just 24.31. So 24.31 grams for 1 mole of that stuff. So 100 divided by 24.31, and I get 4.11. So we get 4.11 moles of magnesium. So the molar ratio between this and this is a 1-to-1. That's going to be easy. So 1 mole of magnesium will produce 1 mole of O3, which is ozone. So that's just going to be 4.11 moles of O3. That's easy. And now we just got to do the molar mass of ozone. So 1 mole of ozone is, now we got 3 oxygens. Each oxygen is 16, so 3 times 16 is 48. So 48 grams. So 4.11 times 48. 197.28. 197.28 grams of O3. All right. So when you have 100 grams of magnesium, you'll produce 197.28 grams of O2. All right, so now we got to compare this and this now. So we have 300 grams of O2, and O is 16, so 2 oxygens is 32. So 32 grams of O2 is 1 mole of O2. So what is 300 divided by 32? I get 9.375. 9.375 moles of O2. Now the molar ratio between these two is a 2-to-1 ratio. So 2 moles of O2 can produce 1 mole of O3. So that's the 9.375 divided by 2. And I get 4.688. I'm going to round that, so 4.688. 4.688 moles of O3, and I can already tell which one is going to be less than, but I'm just going to carry it through just to take it through all the steps. So again, this is still just 48 grams per mole of that stuff, ozone. So then I'm going to multiply 4.688 times 48, 225.02. 225.02 grams of O3. Okay, so we can see which one is the limiting reactant. It is going to be the smaller amount, which is this smaller amount. Now, the question is asking for what is the limiting reactant. So the limiting reactant is the magnesium, right? So magnesium is the limiting reactant. How many grams of ozone will be produced? Well, you're only going to produce as much as your limiting reactant will produce, right? So it's just going to be 197.28 grams of ozone. And that's how you do question number 3. So here's question number 4. Here we have a chemical equation determining the limiting reactant or reagent, same thing, if there are initially 40 grams of P2O4 and 40 grams of O2. So it's another limiting reactant question, which is not surprising for a limiting reactant test. So we are going to have to compare how much product you get from this amount of P2O4, and then we're going to also have to compare that to the amount of product you get with the O2 that you have, and then pick whichever one is less, right? That's just how you do these things. So let's start. So we got 40 grams of P2O4. Let's convert that into moles. So P phosphorus is 30.97, so we got two of those, so 30.97 times 2. And then we got 4 oxygens, so 4 times 16 is 64. So 125.94 grams for 1 mole of that stuff, P2O4. So 40 divided by 125.94 is 0.318. I'm going to round 0.318. So that's how many moles of P2O4 we have. Technically, it's diphosphorus tetraoxide, but that whatever, who cares? Just P2O4. Now, the molar ratio between P2O4 and the product is a 2-to-1 ratio. So 2 moles of P2O4 will produce 1 mole of P4O10. That's a big molecule. So I'm going to put 0.318 and divide it by 2. 0.159 moles of P4O10. And 1 mole of that stuff is, okay, we got 2 phosphorus, so it's 30.97 times 2, plus, we got 10 oxygens, each oxygen is 16, so that's plus 160, 221.94 grams. And so multiply those two numbers together, 221.94 times 0.159, and we get 35.29. So 35.29 grams of P4O10. Okay, that's how much that will make. Let's do the other one. 40 grams of O2. So oxygen is 16, 2 of them is 32, so 32 grams will be 1 mole of O2. So 40 divided by 32. 40 divided by 32 is 1.25. Let's undo that. 1.25 moles of O2. The molar ratio between these is a 1-to-1 ratio. So 1 mole of O2 will produce 1 mole of P4O10. So you're going to have 1.25 moles of P4O10. So again, you can already tell which one is going to be the limiting reactant, but we've got to figure out the number of grams, right? So let's just take it all the way through. 1 mole of P4O10, we already calculated that. That was 221.94 grams. So times 1.25 times 221.94, 277.43. 277.43 grams. Okay. So what is the limiting reactant? Well, it's the one that produces the least amount. And so this would be the P2O4. P2O4. So the limiting reactant is the P2O4. Limiting reactant. Remember, that's also called the limiting reagent. It doesn't matter what you say. All right, so that is that. How many grams will we produce? Well, we can only produce the amount that the limiting reactant will let us, so that's going to be 35.29 grams of P4O10. That is as much as we can get. And that's how you do problem number 4. And here's how we solve number 5 on the practice test. This is the last question on the practice test. It's more of a logic type question than a straight up calculation type. You can still calculate your way to an answer in number 5, but it's not needed. So a chemist mixes 3 moles of potassium chloride with 4 moles of copper nitrite using the following reaction. And it says, A, explain what will happen if the chemist adds more copper nitrite to the reaction mixture after the original reaction is completed. And then it says, explain what would happen if you added some more of the other reactant instead. So the long way to do this is that you could take the 3 moles of this stuff, so we can put a 3 mole up here. You could take 3 moles of this stuff and convert it into any product, let's just say copper chloride, and figure out how much you get. And then we could take 4 moles of this stuff and see how much of the same product you get, and we could compare those two, right? So that would be the calculation way to do this. And there's nothing wrong with doing it that way. You'll always get the right answer. The other way to do it is a little bit quicker and a little bit more straightforward. So instead, notice that the coefficients on all of these things are 1, right? Meaning that if you have 1 mole of this stuff, you're going to produce 1 mole of this stuff. Notice it's not even asking about grams, so we don't have to worry about that. It's just asking for how much, it's more of a logic question. How much can you produce? Same thing here. If you had 3 moles of this stuff right here, you could produce 3 moles of this stuff right there because it's a 1-to-1 ratio. So we're going to use that to avoid, that idea to avoid having to make any calculations. So if you have 3 moles of potassium chloride, you will produce 3 moles of copper chloride. That's just a given. If you have 4 moles of CuNO2, you're going to produce 4 moles of this stuff. So you already know which one is the limiting reactant. It's the one that produces the least amount. It is the 3 moles of potassium chloride. But remember, the question is asking what will happen if you add more of this stuff to the reaction. Okay, so the idea is if you add more of this, well, remember that I'm going to do this right here. We'll do it this way. That the potassium chloride is the limiting reactant. So once that's all used up, you can't make any more of that. You can't make any more product. So it doesn't matter if you keep dumping in copper nitrate. It's not going to react with anything because the potassium chloride's already gone. It's already been used up. So what will happen? Nothing, because the potassium chloride is already used up. The next question says, well, okay, what if instead of adding the copper nitrate, what if you add more of this stuff? Remember, this was the limiting reactant, right? So what will happen if you add more of that? Well, the reaction will continue and then now it just depends on how much you add. The reaction will continue until one of the reactants is used up. Right, it really depends on how much they add, right? If they add 3 moles of potassium chloride, that would mean that, eventually you're going to run out of copper nitrate, right? So that would be copper nitrate would stop the reaction. If you only add like a tiny, tiny bit of potassium chloride, you're going to run out of potassium chloride before you use up the extra copper nitrate. So it really depends on how much you add, but you know that the reaction will continue until one of the reactants is used up. So again, you could calculate your way to an answer on this one, but it's easier just to think about it logically.